Hello and welcome to Tribe Topper. I'm Sonal Gupta, and this channel is about increasing your understanding of physics. To clear your concepts, subscribe to our channel and click the bell icon for latest updated videos. In this video session, you are going to learn about electric potential and potential energy. So if we assume that there is a charge Q, a small test charge, which is lying at infinity, and here we have a big charge Q, which is producing an electric field around it, right? So if we have to bring this small test charge Q from infinity to a position in the electric field of this Q. So P is a point which lies within the electric field of the charge Q. And now it is at a distance R from the charge Q. So earlier that charge Q, which was at infinity, is brought closer to the charge capital Q at a distance R. Then of course some work is done. So the work done per unit charge, that is known as the electric potential. So we'll say work done per unit charge to move it from infinity to the point P. So we will define it as mathematically we'll write it as V, the electric potential, is given as, we can write VE, because VG we used to denote the gravitational potential. So here we'll say VE is equal to the work done per unit charge. So that is electric potential. And from this expression, the SI unit of electric potential would be volts, and 1 volt is equal to 1 joule per coulomb. That means if to move a charge of 1 coulomb from infinity to the point P, 1 joule of work is done. The electric potential is 1 volt at that point. Then comes the energy. So energy is the work done to move the charge, right? The work done per unit charge gives you the electric potential, but the work done, not per unit charge, but work done to move a charge from infinity to the point P, from infinity to the point P, that is called the electric potential energy. That work done gets stored as electric potential energy. So therefore, from this expression, we get W, which is VE into Q, and we know the work done gets stored as electric potential energy. So EP, the electric potential energy, is Q times VE. Now, what is the work done? So work done is force into distance. So if we are moving an object, say by a distance r, then the work done would be the force between two charges. What is the Coulomb's force between charge small q and capital Q? That's given as Q by r square, and this force multiplied by the distance r. So that would give us the work done or the electric potential energy. So Q by R. This is the work done, or we would say the electric potential energy expression. And if we want to find out the electric potential Vp, then that is work done per unit charge. So that would be Q by R per charge Q. So Q and Q cancel. So that's just Q by R. So if you remember, we had a similar expression for gravitational potential, which was Gmm by R, and for potential, it was just Gm by R. Potential energy, it was Gmm by R. Similarly, here we have the electric potential energy as Kq by R and electric potential as Kq by R. So that's all in this video session. In the next video, you are going to learn about the equipotential surfaces. Thank you.